For example, engraving affects metal slightly, but plastic does not. Next comes the printing process. On the table is a pile of finely adjusted white latex, with grooves that happen to print various numbers. Once the lens barrel is placed on it and rotated, the numbers are directly printed onto the exterior. Moreover, the paint is applied to the grooves, so as long as it is not pressed hard, it will not fall off. Next, start installing the inner lens barrel. The inner barrel is made of aluminum alloy and sprayed with a layer of black paint outside. If the plastic is strong enough to resist dropping, Sigma will never let you hang this heavy piece around your neck. After the inner barrel is installed by workers, another lens is taken out, and the front lens is inserted. Since each part has a mold frame, once tightened, screws can be fastened directly with a wrench. On top, there is an inner lens, smaller in size and more compactly positioned. Outside is another lens with a circuit board. Then the flexible cable is inserted into the corresponding position. Because the cable is soft and small, workers must use tweezers for installation. Next, continue applying UV glue. To properly seal the lens barrel, a brush is used to apply along the outer ring again. This reinforces the gap, otherwise dust can enter easily. Place it upside down on the table to facilitate installing the next focus ring. This is the part you rotate when taking photos. Next, install the front lens with the circuit board. Outside it, there are a few screws, not many. They mainly fix the focus ring and ensure the inner dowel is perfectly aligned without deviation. Glass located inside the lens hood is installed, which is also the outermost part of the lens. For example, to enhance colors, people often add a filter on the outside. Now the zoom ring is installed. This is the biggest difference between a zoom lens and a prime lens. Ordinary prime lenses do not need zooming, so they are shorter. Zoom lenses, to achieve better versatility, are larger in both length and size. This comparison is specifically for telephoto zoom lenses. After the zoom ring is glued by workers, a rubber ring is inserted vertically in the middle to intentionally increase strength. When you rotate it, the first thing activated is focus detection. First, the lens is locked and OS starts. The device vibrates continuously at high frequency, recording any possible issues one by one. Light is not enough. Workers must then use AF/MF switch, optical stabilizer mode switch, and recheck all current modes. Once the front part meets standards, the second round of finished product inspection can begin. If the previous step is an appetizer, this step is the main course. Before that, the lens is covered with a casing, slightly rotated to protect the 70 to 200 mm zoom lens. So what is the main course? Look at the patterns on the wall. This inspection uses Canon, Sony, Nikon, Fuji, and Leica, placing the top 5 cameras in the world on the wall and taking photos of the wall with each camera. The first purpose is to check lens compatibility with other cameras. The second is to evaluate imaging quality under that compatibility. The photos are transferred to a computer and examined under magnifications of tens or hundreds of times. If any number is blurry, the lens is deemed unqualified. Moreover, fatigue testing is the most important for every lens, and Sigma is no exception. This process fixes both ends of the lens more tightly, simulating real operational conditions. Once the test starts, it will continue until the lens is completely worn out.